Hmm. Come on, come on, come on. Okay, here we go, bitrate. And we're theoretically live. Okay, I'll give people just a few minutes to come in. Then we'll get started on the code for today. Give it 1 or 2 minutes. Today is rotation and movement. And we'll be able to do a lot of things. If you haven't watched the last one, there's not too much to recap. So this is a tutorial for developing a racing game. We're using all free assets, and then I'll be showing you how I incorporate this into a different game that I'll be building alongside these videos. So you'll get to see a difference between the basic free stuff and also the basic part of the tutorial we go through, and then also a couple extra features that I'll add in for on the side of this tutorial. But all of the basic components will be here in the tutorial. So we're here at 1 minute. We'll go through a little more. So basically, aside from this asset, which is in this project, so basically I snap my package manager over there, do a window package manager, and that'll open it. You don't have to snap it to this one. You can have your setup however you like for your windows, but I found out last Tuesday that if I don't snap it in here, the window doesn't capture it. So everything's in here is going to be snapped in when I'm trying to show people the different windows I have open. We opened the lighting tab, which you can do the same window, and then went to environment and just reduced the amount of light. So light intensity down to 0.8. 0.8.75 is pretty good too, just so we don't have bright, stark sunlight on our scene. We'll be starting to rotate the wheels, and those will be based on the velocity. And I'll pull up the document quick so that we can view some of the other things I wrote down, showing you that outline that I mentioned before in the last video, and just kind of showing how I'll add stuff to it as I keep going in the development process. It's very important that you keep your documents fluid and updatable, reachable by everybody so that they can see what's going on, and also update anything if there's something that's not going to particularly work out for your project or any other type of thing that's going wrong. So we'll download that in a document format. And then it's 6:04, so we can get started on the programming part as soon as that downloads. And then we can flip you over to primary display. And this should work pretty well. Yes. So basically I just added on, I had up till the lighting figured out, like just kind of some sketches for what I kind of want to see. But other things that I'll need to cover are also the race progress. How do we check where the player is, that they're passing checkpoints, that they're completing checkpoints, and who finishes first overall. But on top of the first, we also need something that places the track. So when the track starts up, load the scene, we're going to need to, that's not what that is. Track placement is what the players are in. So each racer has are they in first, second, etc. And that'll probably be in the game manager of some sort, a thing that manages the entire scene. Then we have the racer start placement. So a racer start placement is where they'll be starting the race. Things we might keep in mind if we're doing multiplayer online, meet player and rank. Otherwise, we can do player and random if it's just split screen co-op. You could also do player if you do like a Grand Prix style where it goes through a series of races. You can go through player and rank as well and just rank them as they finish in whatever place they finish in for player 1 and 2 or 4. And we have the finish celebration. So we have playing to fireworks. You never want to. Everything should look really nice, and you never want to make it look too negative, just because it makes players less likely to come back. Even though we all know finishing in 8th place or 16th place in some cases isn't any fun. But you should still try and support that and make them feel like they've, even if it's last place, accomplished something in your race. So then we have the full game cycle. Just keeping that in mind. I don't have any information on that, what I want to do for that right now. So we just kind of look at it. AI, we'll cover the built-in nav mesh later. Not entirely sure what I'm doing with this one yet. But then we have save data and best scores time unlocks. So we'll be saving data. We'll just be doing it as a quick JSON object. We won't be using any additional tools or any of that. Just something quick, simple, and easy for you to keep track of and load from. It follows the current recommended Unity guidelines, which is going to be saving to player prefs. And then we have multiplayer. I'm going to look up what I wanted to do is also do split screen. So we'll probably see if we can handle split screen. And I kind of want this just because people don't always have friends who are going to buy the same copy. And when you're sitting down at a party, it's nice to have games that can pull up and do split screen or single screen, like Smash Bros. Or Sonic Riders or Mario Kart. Stuff like that's really nice to have split screens. Tak in the Great Juju Challenge, I think, it was split screen, and that was a pretty good multiplayer game. Kind of like had a lot of relay elements and was pretty fun. I'll probably cover netcode for game objects a little bit, depending on how far I take this one. But we'll definitely get all the way through the main game, and we'll probably try and cover NGO, netcode for game objects, split screen, and then Peril Sync versus the build and editor. If you're on Mac, you want to just build and run it one build and one editor version, because well, if I get to making that Git video, it's not gonna encompass Mac, so you're better off to just do build and editor in that case, unless you have experience or know people that have experience setting up Mac with Git, and that's just because it's a little bit different. Windows, I can just pull it directly from GitHub and have Git in my console, but it's just different on Mac. And then we might have to adapt some code. That's why we're going to be designing the state machine the way we are for a lot of it. And we're just going to see how that goes. Just kind of keep an eye on it. So what is the idea here? We want to go and we want to start. So, and the view wasn't, view was switched, should be, Might just be the bit rate. Okay. Well, my preview and my OBS are different, so I'm going to assume that this was on camera. So let's head back to the Unity page. We'll look at the Unity page, and we have a nice little bit. So, alright, scripters and kitties. We're going to get started on the basic movement. So I have in here just a prefab of the packages in project. Where is it? System. Packages in projects. It should be listed here. While that's fetching. Top-down robot. There it is. Using the top-down robot asset that you can find in the Unity store for free. You can just download and import that. All I did was drop this in the scene and unpack the prefab. So I mentioned that we just want to take a look at our object here. May contain smooth streaming, such as Able DVR may not be for smooth streaming. Well, we'll see how this goes. Anyway, so we have our top level object. We have our just start recording as well. Okay, just in case it crashes. I started recording. So we can look at the robot. We have a top layer object. This object effectively has no render. These guys have render, mesh render, and materials, which give them their color. This is actually pretty nice, being that the top object doesn't have anything on it. What I usually do is I still like to go and create an empty, so right click, create empty, and then we go and we just make a player container. May not be necessary for every single instance, but it tends to work out more often than not to just use a couple extra objects. Any rate, we'll use the transform property. If you right click, you can just reset it, so you can reset to 0. I'm using this little cheat here that I learned, so if you nest it under here and 0 it out, it brings it to the exact center of this transform, so it'll be at the 0.92. And then if we take and drag that back out of the scene, or back into the scene at the top level, it'll have that 0.92, and we can drag this back underneath this. And you'll notice that this zeroed out completely. That's because it adjusts its world space, its relative transform, to reflect its world space transform. So it was at 0.92, but because this is at 0.92, it just zeroes out the transform of this object. With that, I'd probably call this something like body. So player bod. Player bod's pretty good. And then we'll want to add a component, but we'll want to make that component first. So we go to scripts. I just made a new folder for scripts. Go and create a folder. This one's going to be for Maybe we'll call it eraser movement. Although we're developing the player movement right now, we'll want to develop that and the NPC movement. I guess we don't need to do it together because it's going to use map mesh. So we don't necessarily need to do that. But we might want to. Anyway, we create a new script inside Racer Movement. So we do a new C# script. We're going to go ahead and create something that'll manage some of the stuff for us. So state machine has context and states. So we'll call this racer move context. And then we'll want to create an extra folder I like to do anyway. And this one's just going to be states. Complete the domain, come on. So this one's just going to be move states. Move states. And in move states, then we'll create a script. This will be a generic move state. And with that racer move state, we'll be looking at something else. So with the racer move state, we need to define which ones we want to see. So to start with, I'll look at I'll put the primary display back up. So we put the primary display back up, and it's what I outlined here in my document, what states I want. I want the states of idle, accelerate, dash, drift, grind. Alright, so I'll slide that off to a different window so I can watch this as it works. And while I'm watching it to make sure it works, I want to create racer movement. So we create a new script, C# script, and it will be idle. So I like to throw just something to tell me what it's referring to. So move state idle underscore ms. Doesn't always lead to good names, but it does, however, keep things organized, which is good. So then let's go accelerate. ACCELERATE. Accelerate underscore so there's that one. Create C# script. This gets very boring once in a while, but you only have to do this once, which is the good thing about this. Dash. Oh, crap. Well, we'll show you how to change that in a little bit then. There's a shortcut in Visual Studio that I like, which is the rename function. So we create C# script. So we have dash drift underscore. Alright, and then we'll do another one, which will be grind state. Streaming as views experience. Okay. So maybe my internet's not going to support streaming. Maybe this will all turn into long form videos and just recording times for me, but we'll see how this goes. So we have the last one, which is stun. Looking at stun, all I really want to do here is so this is the idea. A lot of this is based on some old games that had like a dash where you hit people and that sort of thing. So that's where the stun one is. Once you get hit, you get stunned. Just in case we want to do something special with that, not just slow up the rider's speed. And we wait for it all to load. And now comes the really easy part where we just open all of these in our Visual Studio. So double click, loaded, double click, loaded, loaded. Did that stun load? No, now it did. Okay, and then we'll flip over to the other side, which is code. Okay, code. Okay, let's close that and see if this relaunches. We're going, we're loading, we're loading. We're loading, we're loading, we're loading. Does code have a visual now? Still no. Why is this not? Alright. Just add a window. Still not visible. Well, that's garbage. OBS might have problems. I need to roll back or something. What can we do here? Voila! I don't know how I fixed that, but it's all okay. Anyway, so once all these are open, we can see these. Then we just go stun, move, mirror, idle, grind. So I want to make sure my race movement state is over here. I want my race movement state to not be a mono behavior. So mono behavior means you can put it on an object. I don't necessarily want that. So that you can organize codes and questions, you should always put your name at the top with the date. Which it's 7/T5. It helps mark progress as well as kind of inform how things are developed. So I just kind of like to have that so we know who to contact when we break something besides GitHub. I'll just usually just do this for all the scripts when I start my day. Didn't quite work for that one. There we go. It's just a little laggy because of the video software running at the same time. But essentially in here, we're going to make all of our different states and what they do. And we're doing this to keep the code simple and easy to use, as well as changeable when we go to make our multiplayer version. We want a lot of this stuff to be inherited and usable on not just our single player console type release. I'm gonna Control Shift S, Control Save all. And raise your move state, regular script, regular C# class, which means none of this can actually run. First thing I do whenever I create a new script is I usually delete that. Just because most of the scripts you write, especially if they're not mono behaviors, are not going to use start or update. Regular classes can't, but quite often I don't find myself using start or update on mono behaviors either. So the layout that I was taught as industry standard was for C# that you like. I think for Microsoft style, they want vars, what I call variable accessors. Then I think it's constructors. I want slashes in front of that. Constructors. Methods. I think that's the right way to do it. They want you to do it. When working in Unity, I actually have something else that I like to do. I like to put the accessors down here, and I like to go and take constructors, put them right before the accessors. And then I actually have a secondary one in here that really just applies to mono behavior objects. I call coroutines. Probably cover coroutines later, but right now coroutine is basically, in Unity at least, it simulates a independent task. So you can have multiple coroutines running at the same time on a time delay, independent of each other. It simulates separate threads, but in fact runs on one singular thread. That's all of them run on one thread. So processing wise, it doesn't make a difference between just executing in a normal fashion, but it does make a difference in terms of how can I script it, which does make it easier to script delays and such. Any rate, move state. I like to go back here to, you remember in the race movement folder, there's racer move context. So I'd open that. And then racer move context has start. And we're looking at, so we can get rid of this. Racer move context will be an auto hit behavior so that we can use some of the Unity event type stuff and other things in it. One thing in Unity, the new Visual Studio likes to auto add some of your Unity and using statements. It doesn't do a very good job at it. Sometimes you just might have to check your using statements and make sure that it didn't add something extra that it isn't supposed to be there if you get any errors. Shouldn't run into that too much on this type of project, but on a mobile project it becomes quite a pain. So erase remove context, we do want this to be a mobile behavior or a mono behavior. We also want it to have the same things, even the copy. Yes, I'm very fat fingered, so I bump keys all the time. We have Unity domain is loading. Cool. Bars. So move context. I've usually set up a couple different things. We'll use region right away here. So region is basically just a way of organizing your code. Doesn't mean anything to any programs except organization. So we have hashtag region. Then we can label it bars for state context. So maybe we should just states state creation, because we want to create the states before we start using them. And then we go, maybe leave a line open. We want to use our end region, hashtag end region. And in here we'll put our states once we set those up. Just wanted a couple other ones. I also want to manage my current state, so vars to manage current state. Vars to manage the current state. The reason we want to manage the current state, why we don't want these two together, some sets will have like 8 states that we need to switch between, and we don't necessarily want to look at them at the same time we look at some of these. Especially with the new way I've been doing it. So, end region. So variables to manage the state, then we have end region, methods, coroutines, constructors, accessors, all blank. So race remove state, it's going to have methods, and the ones we want move state to have Some people use public, which would let everybody see them. I like to use, others say you should use private all the time. I like to use protected. Some Java creeping in there, capital P. Protected. And what this is going to be, it's going to return should return a move state. Yeah, so it should return eraser move state. Let's get a basic one in here. We want everybody to have this that inherits from eraser move state. We want it to take in a move context as state mission. So we want eraser move context. If we have eraser move context, we need to label what that variable is. Start with lowercase a, RCM, eraser move context, RMC, eraser move context. We go down here and we'll return we'll just return what this is for now. So this is returning to the move state, which does work, but isn't quite what we want. What we'll actually have is we'll have a stun. What we'll actually have is a void. So void, I don't want any return type. What I'm actually going to do is use this ARMC and change its state by that. So I'm going to go into my move context and look at what I need. Let's go ahead and build our stuns first. So when we go into these, it's been a while since I've done this one. So let's just delete everything for start and update in all the classes, in grind, anything that's going to be a move state. Just empty it all out. Once this is all empty, we can look at what the methods are supposed to do. So the methods are going to be to change the state of the race move context. And they're going to do so by calling methods inside the context. They're also going to exist on the context because the context is going to create them. Which means that in order for this to work, we're going to have to load the domain. And once that domain loads, we can continue working. So erase remove context. Everybody should have a method that is void, and we'll probably want to call this something like, we'll start with the first one, which would be average be accelerate. ACCELERATE. Return. So we're not going to return anything. We are going to take on an ARMC first. And then we are going to want And there's two ways to finish this. There's either the part where we take and we go a RMC dot, then we would access its property and set it, or we can call a method, but that's going to be a lot of methods, so we'll probably set it. So erase remove context, and that's where this management region comes in, is that I want it to be, I want my current which would be a state of erase remove state. Erase remove state. I want my cur. It's easier for me to copy and paste. Current erase remove state. And then don't set that here. What we'll actually want to do is set that one at either awakes or enables. I don't want to do that on start. Start's kind of bloated. So we have var for state creation. I haven't done anything yet. What we will want to do there is then, so we have accelerate, which should not inherit from mono behavior. It should inherit from erase remove state. So now it's inheriting from the move state. So we can make our move state list here. So then we don't want that. We want it being want to accelerate. So what do I want to name this? I want it to be a erase remove state, which is probably lowercase accelerate, just go underscore ms, and that can actually equal new accelerate ms, the parameters of empty, because we don't have any constructors that require anything, so it just has the empty one. Just kind of setting up framework still. We haven't really started on the big part yet. So eraser, current, eraser, move state. So now we have current eraser move state and region, and we're going to move on to accelerate. So accelerate has erase move state, so let's copy that and just make sure all of our dash and everything inherits from that. Drift, just go down the line. Make sure that we select correctly. Yeah, tab complete. That's a neat one. Wonder if it shows up on recording. Doesn't look like it does. It's interesting. Working with Unity, which is so graphical, you start to recognize the behavior underneath from what is displayed. So it's kind of funny to see what shows up and what doesn't when you do window capture through OBS. So ARMC and erase remove context. Context, I want these to be protected. So once these are protected, that just means nobody else can write to them. Other people can still view them, but they can't write to them, which is pretty important. Depends if this was a secure thing, like piece of data that needed to be kept from visibility for security reasons, that would be a problem. But just it being this and not having the ability to write to it is fine enough for most cases, at least in game development. Methods. So we're looking at methods. Then what do we want to do? We have a method, nothing that we're going to change yet. Go back to accelerate, or we're likely back to here. So accelerate, let's make the default one, set it to the move state that is stored in race_remove context. So it's arms, it's accelerate. And what we want to do there is we want to create an accessor for that. So a lot of people will call these gets and sets. I like to use the term accessors because all I'm doing is determining how much access it has to a variable. It organizes my code a bit cleaner. So let's go ahead and Control-C, and then let's go down here, accessors, accelerate, and we're going to call this something different, just with a capital letter. Then we're going to go ahead and make this part public, and then we use brackets. And this does autocomplete for me, so I can choose get return accelerate ms, and that gets us the accelerate variable that's up there and returns the race_remove state that is accelerate. Just make sure we're referencing the correct thing. So I go to race_remove state. And then current state, meaning that we need to set this. So we need to change its current state. So what can we do to change the current state? Well, we can make it public, which doesn't help much either. Or we can create a method to change the state, which I think might have been the one I used on the last state machine I made. So if we create something in methods then, so we create this region that is change states, and we end that region. So if we change the states and we end that region, then what do I want to do? I want to create a method that changes the state. Okay. Just might not want to do that here. Because change states can go, we can have a, let's go with the protected for right now. Protected void that is change. What happened? Freaking autocomplete. So we have a thing that says change states. Change state. and we want to pass in, no. Okay. So the idea is our input is going to be an input, and it's going to look to the move context for part of this. And the move context comes down and changes the state for us, which is its movement state. And all we have to do is daisy chain down and get to it. So what do we want to do there then? So change state is that we can change the current state through this, but we don't really want to, which is where we can change it to give back a racer move context, accelerate, that's incorrectly typed, state. Nothing beats copy paste. So move state, and then let's just return, and let's just make the default this, or no, ARMC dot accelerate MS. Yes, because I want to call it and I want it to return what state I'm supposed to move to and then change my state. So change state should take in your code up here. So we change state, we change coroutines, we change constructors, we change accessors. Change state. Change state occurs when we need to change state, runs into this. So I need to change from accelerate. Let's just add another one. So we got some more. Protected, race mover stat, don't need move, we need sometimes you have to go back and forth a little bit when you're working on stuff, just so that you have enough things to test it out with. Even if you're just going by autocomplete and logic, your own logic, you need to keep an eye on that. It's like, am I outrunning this part of the class where there's no other things here? Racer, let's go ahead and just fill this out. So we have stun, idle, underscore. And if you hit blocks too, it's best to just fill out your classes as best you can. Try and get a better idea of what you're working specifically on. So idle, grind, protected, grind. A bit like this is starting to feel. This is perhaps the most boring pattern I use, and I only really use it for movement controllers. So it comes to grind, If it weren't so useful, I probably wouldn't take the time to set all this up, but it does save a lot of time on other things. New grind MS, protected. Erase remove con, nope. State. If my stream doesn't make it out, maybe I'll shorten this part to just be sped up in the video. Drift, dash, last one dash. So dash ms dash move state. Oh, and then make that equal new drifts dash. Make that new dash. Alright, that's correct. Now would be a good time, since I noticed that, to go change that. So let's go dash. The function is really easy. Select, right click, and rename. It's towards the top, it's like the second one. And I want to rename that dash MS, and hit enter in that box, and it'll change all the references in project as well. So then we go back to here, and it'll change our dash MS to here. So now that's fixed. Let's go ahead and make sure we do a save. And we're hitting 6 o'clock. This is a long pattern. Okay, so accelerate, erase remove state equals accelerate equals that. So then let's go and check out our stun, our idle. Okay, so this returns it so that it changes it to this state in the context, which means your change state should go to its, I think I had a method that ran accelerate, all separate methods in the move context. So let's see how that goes. So it should be like we did for accelerate here. Let's just replace all our names. So copy paste the whole thing several times. We'll go stun, and then stun ms. What's dot spelled wrong? Oh, right. No accessors. All right. Autocomplete's fairly quick on this, so we just do public erase move context. Why does it keep doing that? Stun ms, get bracket return the stun.ms. And then we need to make sure there's that's an executable line, so semicolon. Racer move context. Why? Okay, forget it. Let's not do it this way. Let's do it this way. How does this work? Line. What happened? Okay. Let's do it that way. So it's stun, then it's idle, 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 then it's grinds, grinds, then after that it's drifts, drift, and there's drift, and we get to dash. Okay, saved up. So we have stun, idle, idle, and we're just doing defaults. We'll change these in the individual ones later anyway, probably, so it's not super important, but you want to make sure that it's returning something that makes sense. Idle, and then we have so we have grinds, and then we have accelerate, and then we want drift, then we want drift, and then we want dash, let's change these back here, grind, and then we have drift, then we'll do a dash. So then we have dash ms. Okay. So we have all these. So then racer can move in context. Right, because the controller is going to want to change these things and change inputs and set that type of thing up. All we need is the ability to change states. So these guys return to the ARMC. And then we're going to do that quickly here. Inside this change states. These are a little bit different. They won't be protected because other applications are going to have to call these, or other parts of the application will have to call these, and we don't want them not having access to that, or it would have to pass through like a integer or something. We're just going to do it the simple way. We're going to do a just a different method for each one. So we start on the left, we have stun, and capital stun, not MS. This is the public stun, and it's going to be a void function. And here's the fun part about this particular design is we don't have to assign it or figure it out in here. What we're actually going to do is just, okay, we need to do stun. So we're going to like we're going to change the state. We're going to change the state. And we're going to create a next state variable, which will be a player not player props. Come on. Let's just go grab up eraser move state. Erase move state. NXT NXTMS is equal to the current eraser move state. Should rename that. Current eraser move state. And that's it. That's the line. So, oh, but we don't actually want that. We want dot. We want dot stun. We call the classes accelerate stun. Oh, that's right. Stun, and we just need parameters. Give it the argument of this, which would be referring to the eraser move context in this instance. It still doesn't like that. Why doesn't it like that? Inaccessible due to its protection level. Right. Right. My reflex to make everything protected has protected too much. This is supposed to be public. Okay, now that those are public, we can actually see them and use them. The amount of times it comes down to something that you just mistyped. Classic. So we're looking at eraser move state. We're looking at current eraser move state. We got stun. Okay, so now it'll go and return this. So we get what the stun state would send us to, which is currently stun. And we send the current context in so that it uses the correct stun state, which is the one on this particular object. And we have change state, which is what I started to write up here. So change state, it should just take an eraser. And here you can kind of see where I'm like, where I had the, it was mostly in the right direction. It was just a bit ahead of itself. So it was tripping me up a little bit here. But once we got through into the part where we started making the methods and we had the correct things to put in the method, then it made a lot more sense, and it probably makes a lot more sense to anyone watching this now than it did when I was just fumbling around with it's supposed to change the state here. I will have one placeholder method that I like to have. This will be protected because only this method should use it, much like change states. And I want void of any return type, and I'll add a protected hold. What is it? I want erase remove state. Erase remove state. I want it to be the last CM the last MS. The last RMS maybe. Last RMS. And so I'm going to rename it. It's going to be like that one. It's going to be cur RMS. And I'm going to do something that may look a little dumb to some people. It is, okay, so protected void. Change. There are other ways to do this, but I like this way. No, I don't like that way. And this auto-completed wrong. It's a state. This is also going to take in a state. And RMS. So last RMS. And this might actually not be used at all, but it's here in case I need to make it less complicated. Change less state. So yeah, we're gonna make a buffer state. So this is gonna be racer move state. And it's gonna be a buff ms is equal to cur RMS so its switch could just be this. No? Yes. Because this is the one we want to move to. This is the one we want to move to. But we haven't changed it yet, so no. That was, yep, confusing myself. It's not that hard, but it happens a lot. Oh, so it happens a lot, I guess. Racer move state buff ms current move RMS. So our current racer move state, we're saving that in a buffer. Then we want to look at, so then we check if we're in state. cur is equal. So if the current state is equal to the last state, 715, current state equals last state, then it's equal to, then we don't want to do anything. And then if it is not equal, where is it? Equal sign. If it's not equal, change last. How do we check if they're equal? Well, we can't do a state comparison because comparing object addresses doesn't work very well, so we can't just say if buffer state and next state are, if this is true, then do that. We can't really do that. We need something to keep track of if it's true. So cur RMS, if current is equal last, we do nothing, and if it's not, then we change the current one into the last one. So what we need is some booleans or integer values. The best way, I think, is to just do really dumb boolean values. So let's go back to our eraser move state, and those are also going to have to be probably protected variables and then given accessors so that no one changes them or writes to them. So we're going to look at methods, and what these guys are going to go to is, I'm just going to check my view real quick. View hasn't changed. We'll see how the video ends up. It comes to eraser, move stat. I just want to make a region here quick so that I can continue to operate sanely. So this is going to be state change methods. State change methods. And then here we're going to do end region. This might look really complicated, but I swear it's a lot less complicated than the one I used to use. Quite a few people that worked with me can agree on that. There's just a lot less moving parts, a lot less difficulty in reading it. Everything's a lot more buttoned up, so to speak. And then those vars. So we need protected B move states? No. Protected being booleans. And since we're here, let's just make a region. And this is boolean. Let's just call that state booleans. State booleans. State bools. State bools. So we have a protected type bool. And we'll just make this is. And then, well, we'll just start from the left again. Is stun equals false. And then we'll just make those. So Control D at the end of the line duplicates the whole line. So then we go is, and a good amount of people that watch this video can probably type faster than I can. Grind is drift is dash as accelerate and this is extra. So we'll just delete that line because accelerates our last state. So then let's save that up. So just default all these to false, really good. I can go into here. What do I want to do? Protective bool. So these are inherited. We can change what they do. I need to end that region probably. Hash end region. Okay. So bool, and then accessors. Lots of typing, lots and lots of typing. If you think you're going to get away from typing any kind of variables, it's going to be a majority of your time. The methods are easy, the variables are long. So is done. So is done is equal false, and what do we want to do? We just want to do is, well, that's not, this is wrong. Because if we're going to do getters, setters, those should be capitalized, and these should be lowercase, meaning that so in accessors, public and you could probably do, yeah, I don't know how much I like that, but doing a public get without just defining it outright in one line, there's ways to do that. I just do this for my peace of mind. So is stun get return or no. Yeah, because all I need is a get. Let's walk it back. Think it through for fully yet. Okay, so do I want all these booleans here, or are they just accessors? Or are they just, because I don't want them to be able to be changed, which means an accessor works out fine. Which means I don't want, which means this is redundant. So it should be, I just want the names, so Alt-Shift, copy. That's not quite right. I want the bool as well. Put in accessors. Okay. And then I want Alt-Shift, create a big line, and this is going to be public. That's just a little shortcut. You can do it by hand, but it's really just not worth the effort when there's a tool to do it for you. On Windows, you can just, in Visual Studio, you can go Alt, and you can make a whole line. So anything you type here will be that way, and also that's how I did the selection, is Alt-Shift, and you get a rectangle selection of space to space, and it works really well visually because, like, the reason you can see it work visually is because this is a monospace font. If it was not, it would be, the selection area would be a bit wacky. So let's do a get this way. Return, we got public bool is stun that we want to return, and what is our setting? Our setting is false stun line end, and that should be the default for all of them. So let's go Control C. Let's just clean these lines off. Then let's do an Alt-Shift this way. Try this out. Whoa! Beautiful. Kind of. Something about that tells me type racer move state already contains a definition of his stun. Right. Let's do another shortcut. Control Shift slash. Insert star slash. Comments for you. So that code's commented out, which means it won't be read, which means we don't have to worry about it. So since that's not going to be read by Unity, that leaves this right here for our project. Everything returns false by default. Then let's go to this. Let's go public bool, and then I want these all to be readable, but I also want them all to be readable, but I also want them all to be overwritable. So I'm going to throw in the virtual keyword. If I remember how virtual keyword works. It's lowercase. Virtual, then I can override it, which is what I'm going to do right now in stun. So bars methods and then accessors. And what do we want to do in accessors? We just want to overwrite that one. So we do a public over, is it lowercase? Override. It's not a void return, it's a bool return of is, I will do is stun because this is stun. We don't want it to be base. I'm not sure what this means. That's bit shift base. Is that just bit shifting the? That's just basically looking for that bool. Okay. That's just saying it's doing the same thing as what's in the base. It's written that way because it's a get. So what I'm just going to do is I'll just define it outright again. We got a get, and that get return t true, and then remove this semicolon. There, that's all working. Reason being, I want all the other ones to still return false, and I just want to overwrite this one. I just kind of do this for each state. So more typing up ahead. But let's actually go ahead and so let's go back to here. Now, much like the variables right here that we wanted to override, we also want to be able to override these later. So now would be a good time to put in the virtual. Virtual. Again, this just means this will happen unless otherwise overwritten in a different place. That's all I wanted there. And because of that, let's go ahead. So state change methods through this green comment is what we have in every single racing method. So let's just copy it. So methods through to accessors line. Now we're just going to go here. I'm going to go ahead and paste that in. And then I just do this because it will be ready for me to override later. Because usually you do end up adjusting each one, or you can just delete it later if you don't end up using it. But it's good to get this set up out of the way so that you can then just do all this as you're moving through. So then let's go ahead and copy this. Methods through accessors again. Let's put it in idle. So we have our overrides all the way to our accessors. And that one. So we'll probably put bars in if we ever add some variables. Dash. Save them all up. And it looks like I might not reach the get this all done by the end of the stream. So it'll probably pick up wherever I leave off in a little bit. We can get the states hooked up to be changing. So we have end region, all these connects. So maybe I'll just show the, maybe we'll just get one state change running, and then it's all very replicable for the rest of it. So we'll do that. Looking at current RMS, and so we got the RMS, that's saved in a buffer. Check if our last is equal to do anything. So now we can go here, and the way I would check is maybe we'll put if alright, if the buff ms is not equal, and we actually don't want the ms, we want the buffer. So if the buffer states is stun returned is not equal to the that's not quite right. Alright, if the buffer ms is stun, might have actually used integers for that. What would it be? It would be, because we should check that not equal last RMS dot is stun. So if those booleans don't match, then this would return false, which we wouldn't do in change states. We'd actually probably do that in stun. So instead of having any of this in here, we'd probably do something like this. We'd find our next MS, which returns what dot stun would be. We'd get our buffer, which is our current RMS, which just for safety's sake, we should probably put first. If this happens, so then in stun, if this has happened, that means that our last state was stun, and we don't need to change our last state. Okay, so our buffer is our last. Buffer is current state. Next proposed state is stun. And then, yes, because we're checking if our current is in fact our last, because we'll be moving on to this. And if our current is our last, then we don't want to change. But if our current one that will change from if our expected one that we want to go to is different, no. If our current is different than than the expected one, then we want to change. Or if our expected is different from current. So that would be if current and expected are different, then we want to then last. Yeah, so this should be MS buffer. So if buffer is different, so if current is different than next, so if current is equal to next, is not equal next, then last MS, what did I call it? Last RMS. Last RMS is equal to cur RMS. Yes, because if our current, and this should be dot stun, this might not be exactly like my last one, but it should be. It's done. Alright. So if the current RMS is stun is not equal to RMS stun, last RMS is equal to current RMS. And then the only thing you have to change is the access here. So it pushes to something else. This should correctly update our dot stun this. So this returns our next. Buffer isn't used. And we can remove, so this runs, and we can call change state, which is just setting the state equal to whatever's passed in. Cur RMS is equal to ARMS, and we change the state. Change state with next MS. Then that should be good. Then everybody can just use this, and you don't have to change this line when you duplicate it. You just have to change the stuns and the variables you're looking at, because it's always the same object we're looking at. So then we would just fill these in. It's looking like 20 minutes too, and that's actually going to be a lot of typing. So maybe we'll break this up into two. We'll resume this Saturday. I'll go ahead and type those things in, get some of the just that repetitive method typed out, get that all typed out, and then we can resume into inputs and the new input system. So if you're following along with this, I would just recommend finishing out this, doing this same method for the idle grind, the rest of the move states, and then also installing the new input system would be a good thing, which all you do for that one is you go to the Unity. Let's go to Unity, and you go Window, and what do we actually want? We want It's in the package manager, which I have open. And what that's going to be is it's just you go to Unity Registry, search for input system 1.7. You can install that. I have it installed so it prompts me to remove, but you can install that. You'll have to restart your project and you'll be ready to go. And all right, so I'll finish up typing out that long set of methods, recap it at the beginning of the next stream or recording, and we'll take it from there. Finish off the state machine for the movement. All right, so thanks for viewing, and if you have a question, drop it in the comments. Yeah, be sure to drop it in the comments and let me know if there's any questions, so I can review it in the recap for the next recording. All right, thank you.